Good afternoon. My name is David Moser. I'm the head of the Photovoltaic Energy System Group at EURAC Research in Bolzano, Italy, and I would like to welcome to this session of the Solar Quality 2021 conference dedicated to innovation in artificial intelligence and data-driven quality management. If you can go to the next slide, please. We kindly suggest you, if you have any question, to drop it please in the control panel. You will see the instructions here, and please make sure that you also, together with the question, you can also type the name of the panelist the questions is referred to. I will take the questions at the end of all the presentations. Today we have, together with me, we have a very important list of panelists. We will hear from different perspectives on how the sector, the PV sector, especially in the field of operation maintenance, is moving in let's say, with the topic of data-driven quality management. So we will hear from Hitchcock, who is founder and CEO of Above Surveying. We will hear a presentation from Schütze, who is a data analyst from Greentech, Julian Dax, product manager at 3, and Ramon Castillo, solution manager at Huawei. I already introduced myself, and I will be your moderator for this session. So the first presentation will be given by myself, and this gives me the chance to present you just a few slides about the Horizon 2020 project, Trust PV. So Trust PV is a project that started 1 year ago and will last for another 3, and where innovation in AI and data-driven quality management is quite prominent. So just to introduce you the, let's say, the members, the partners of the consortium, if you go to the next slides, you will see that we have a very high industry-driven consortium dedicated to several topics, between which the topic of this session. So in the next slide, you will see how we tackle quality within Trust PV. So for us, Trust PV is a value chain approach. So we want to really improve the various objectives, going from the design phase of a PV project through the EPC phase, so the engineering, procurement, and construction phase, to operation maintenance until the end of life. And we want to do that really by looking at the development of new methodologies, both during the design phase and during the operation phase. And those methodologies, they are really data-driven. So if we look a little bit at the expected results of the project in the next slide, you will see that what we're looking at improving and developing exploitable results at 3 different levels, going from components level to system level until the point of connections. And if we focus at the system level, you will see that we are really looking into how the digitalization of the sector, together with data-driven results, can further improve the daily activities in operation maintenance. We will hear during the next presentation some really concrete examples from partners of Trust PV, but also from other prominent actors in the sector. So we want to look into cost-effective fault diagnostic. Of course, reliability is an important issue that we want we look into in Trust PV. And one of the most important exploitable results is the creation of interoperable platforms for enhanced decision making. So if we focus on these results, here are a little bit in small fonts. In the next slides, you can see a little bit in a larger print. We can see how really we want to do it from both the data which are monitored in terms of performance and measure, but also we want to look into data-driven analysis in field diagnostics. So if you go to the final slides of my presentation, for us, the future is really to be able to combine all the data-driven mitigation measures that can come from advanced PV plant monitoring, together with the data-driven mitigation measures coming from advanced PV field inspections. There are some components that at the moment are, well, they are state-of-the-art, but there is a lot of R&D that still needs to be done in terms of geolocalizing components within a digital twin approach, I mentioned already before the need of interoperable IT platforms, the needs of also of the, let's say, the opportunities of introducing new metrics, for example, metrics able to assess the economic impact of failures, and all together we can really derive optimized operation maintenance strategies. And thanks to optimized operation maintenance strategies, we can think about having new contracts that goes beyond the typical contracts between asset managers and operation and maintenance operators, and everyone who develops services for these two stakeholders, and also to develop decision support systems able to suggest to the operator in the field what is the best action to be taken from a cost-effective point of view. So this is just to give you a brief introduction on how TrustBV is tackling the issue of this session. And without further ado, I would like to thank you for your attention so far. And I would like to go to the next speaker. So the next speaker is Will Hitchcock, founder and CEO on Above Survey. So Will, the floor is yours.
Thanks, David. Hello, everyone. Yeah, so my name is Will Hitchcock. I'm the founder and CEO of Above. You can jump to the next slide, please. And the next one. Yeah. So Above was founded in early 2016, was set up to address some of the challenges that the growing utility scale solar industry is facing. And our innovation focus is sort of to address three key challenges the industry is facing: huge growth in the speed of PV deployment and in asset size, increased life expectancy despite questionable component quality, and very high levels of human intervention throughout the solar asset lifecycle. So some relevant and thought-provoking stats for you. 80% of the cost of solar asset management and maintenance is human resource, and this is the highest in the energy industry. And 70% of deployed solar is less than 5 years old. So some stats to think about. Next slide, please. So Above offers a range of services which deliver value throughout the asset lifecycle, from the early stage development through to operation. So topographical surveying, so we use photogrammetry to capture highly detailed terrain and shading data for onward array design and yield modeling. Construction monitoring, again using aerial photogrammetry to monitor and record construction versus design for quality assurance and accurate progress reporting. IEC compliant thermographic inspections to chart module condition and DC system health from commissioning through EPC milestones and then on into operational life. Then 3D modeling, so using intermeshing photogrammetry, we can digitally reconstruct existing assets to check for construction integrity, for azimuth, incline, and pitch errors. And then lastly, our ultra high definition scanning service delivers a detailed scan in the visual spectrum to identify more subtle anomalies that are yet to produce a thermal signature, but are of concern for the future for that plant. For example, delamination, snail trails, and busbar corrosion. And all of these services are delivered through our cloud-based platform, SolarGain. Next slide, please. So interacting with SolarGain and inspection, test, and monitoring data on site is really vital for the reducing that 80% figure that I mentioned earlier and increasing maintenance resource efficiency. So Above offers a suite of mobile applications which link to our SolarGain platform and allow our customers to record, track, and manage activity, capture imagery in real time within the geospatial digital twin. The next slide, please. So our SolarGain cloud platform provides a hub for all forms of testing, inspection, and measurement data, and that's data that could have been collected by Above using drones or ground-based third-party data, and it allows you to connect third-party services such as monitoring systems or CMMS systems, and enable you to view, analyze, and correlate previously siloed data sets. And the Gestalt theory is one that really explains the sort of value in this quite succinctly, that an organized whole is greater than the sum of its parts. Next slide, please. So the digital twin, SolarGain digital twin, stores the data with a structure which understands both the electrical hierarchy and the geospatial layer of the solar plant. And then it enables you to layer on other data like component metadata and other testing and inspection data. And this way of storing and surfacing the data allows you to digest information in a multitude of ways and easily identify relationships and trends and other valuable insights previously hidden from view. Next slide, please. And then onward into operational life. So layering and correlating data provides immediate value, but over time, the temporal data increases the value exponentially. The industry needs to embrace component level condition monitoring, and with our digital services, this can be achieved robustly and efficiently. And charting component state change over time is vital in the context of preventative maintenance, spares management, repowering, and warranty claims. Ultimately, these solutions are leading the industry towards the utopia of predictive analytics and predictive maintenance. Thank you very much for your attention. I'll hand back to David. Oh, hand on. Thank you.
Thanks, Will. As you see, I'm talking to the audience. As you see, we asked the speakers to be very brief and thought-provoking. So in the meantime, make sure that you drop some questions. And without any further ado, let's move to the next presenter, Hannes Schütze from Greentech. Hannes, the floor is yours.
Thank you, David. Yeah, hello to and welcome to today's discussion on innovations in AI and the solar industry. My name is Hannes Schütze, and in the next few minutes, I'm going to introduce my company Greentech and show you our latest artificial intelligence project so that you can see how AI can be used in the solar industry as a value generating tool. Next slide, please. Thank you. So we as Greentech are an integrated PV specialist. For our customers, we offer the full range of services needed to be successful in the solar industry. That is project development, system design, plant construction, and, which is our key skill, the operation and maintenance of PV plants in Europe. We are an interdisciplinary team of over 100 employees at several locations in Germany and the UK. And we are currently managing a growing portfolio of more than 900 megawatt peaks. And our main business focus are operation and maintenance services for our managed PV plants. And to ensure the best and most efficient service for our customers, we put a special focus on automatization and continuously improve our data-driven solution. And that is also what my role in the company is about. If you could go to the next slide, I'll briefly introduce myself. I'm Hannes Schütze. I'm holding a master's degree in mathematics and economics with a focus on numerical mathematics and graph theory. And in 2020, I joined Greentech as a data scientist with the mission to implement data-driven models to ensure an optimal and efficient O&M service for our customers. I'm really excited about the, if you just could go back one slide, thank you. I'm really excited about the opportunities in the solar industry, and I'm really passionate about applications in AI. And I started with projects around automated failure detection, and my most recent focus lies on snow and vegetation detection with artificial intelligence and with image recognition based on webcams on-site cameras. And that's also the project that I would like to introduce to you now on the next slide. So with this slide, I would like to show you how we improve our monitoring alarms by using AI algorithms. So the basis is data, and we have a lot of that we can access in our modern PV plants. More and more data becomes available from on-site sensors and also off-site resources. And at the same time, storage and computing becomes cheaper And also there's a wide range of open source algorithms that you can use. So one thing that we do is image recognition based on on-site cameras. Our AI algorithm can automatically recognize snow on solar modules, and I'm briefly going to take you through this. So there are 9 pictures, and if you look at the first row, the modules are free of snow, everything looks good, and they should produce normally. In the middle row, we see that modules are covered with snow, and thus we expect a much lower production. And the algorithms that we tested so far are very reliable in correctly identifying these cases. But then in the last row, we also see that there are quite a lot of special cases that are also important to recognize. So it's not just enough to detect snow in general, but if you look at the picture on the left bottom, there is snow on the ground, but not on the modules. Thus, production should not be affected. Or we can have construction going on or sheep. And the good news is the algorithm is also able to correctly identify these special cases. But then an important point for me is that it's not just enough to develop such a product as a standalone tool, but it is critical that we integrate the insights that we get from these kind of algorithms into our existing architecture. Yeah, we need to combine the results with other data, other sensors, and integrate them into the existing processes to actually add value. So how this can be done is shown on the right in the decision tree in this routine. So if our monitoring portal recognizes low production, first a seasonal check can be performed, can be checked. Is it actually winter? How are the temperatures? And only if snow is generally possible, the algorithm comes into place. It pulls a picture from the plant and it can detect, is there snow or not? And only if snow is detected, an alarm will be raised. But, if snow is detected, then the system, of course, would remain silent, meaning putting the information into a separate tracking list for reporting, and only if there is no snow but still low production, that's the case when an alarm should be raised. So by this, we significantly increase the accuracy of our alarms, which is very helpful in the winter months with many plants covered with snow. And this lets us also detect real outages. So I hope by this I could give you a brief idea on how AI will be useful in the solar industry and also how it needs to be applied. I'm very happy to be here at the Solar Quality Conference, and I'm looking forward to our upcoming discussion. Thank you.
Thank you, Hannes. Let's move to the next speaker. So the next speaker is Julian Dax is a product manager at 3E. Julien, the floor is yours.
Thank you, David, for the introduction, and thanks for the opportunity to participate to this panel with such interesting people. If you can move to the next, and then still the next slide. Yes, just a quick introduction of 3E for those of you who do not know our company, but I'll stick to the essentials because time is limited, as David said. So 3E was founded in 1999. Initially as a consultancy company, and then in 2010 we embarked on our digital journey with our monitoring platform, Synaptic Asset Operations. Something went wrong with the formatting there, but hopefully you can still read it. And then in 2012 we launched our digital twin. It was already mentioned by David as a very important aspect of performance management, and I think we can say that we were pioneers in that. And if you go to the next slide, that just adds a few names of research projects that we've been working on ever since to continuously improve this digital twin, and also to develop the performance management based on that, leading to the launch actually next week of our advanced analytics module on our platform. Next slide, please. So here, just an overview of what our methodology is and how that digital twin is put to good use. So based on measured meteorological conditions and based on the digital twin of the plant, our system or our simulation framework will estimate or simulate the nominal yield, the expected system losses, and then the expected yield, much like, for instance, PVSys would do. It's as if we run a PVSys simulation on a continuous basis, except it's our own simulation model. And that gives a very good foundation because we know what the plant should be producing at any 15-minute block in time. That gives a very good foundation to go analyze the gap between expected yield and measured yield. And from that, we can quantify, identify and quantify the unexpected system losses. What is causing those losses? And then some of these losses may be recoverable. So that allows our system to come up with recommended actions so as to recover yield for that specific plant. So just to make it a bit more tangible still, maybe on the next slide, you can see these two waterfall plots. Hopefully it's a little bit readable. So the left one corresponds to the expected losses and the right one to the unexpected losses. So expected losses going from energy nominal to energy production simulation and all of the system losses that are commonly expected. And then on the right side, going from energy production simulation. So the right side of the left graph is the start of the next one. You could see this as one big continuous waterfall plot going from the simulation down to the measured production. You see that we are able to identify a whole lot of loss categories, and we're even adding more of them. I think we probably have the most separate categories of any product that I've seen, at least. And I do believe that that's thanks to our very detailed, accurate, and granular digital twin that we have. And on the next slide, I will give you an example of why that's important, because as I said, our digital twin and simulation model is calculating the expected power on a 15-minute granularity. And that can be important for things like inverter clipping. If you have a high DC to AC ratio, you can have inverter clipping, and that often will happen on a sub-hour resolution, or yeah, in smaller blocks of time. So left and right are exactly the same plant, exactly the same day, and the power is plotted on a 1 hour granularity on the left and on a 15-minute granularity on the right. And you can see how there is inverter clipping on the right that you miss if you're looking at it on an hourly granularity. So that's just one of the examples where we try to be very accurate, because if you don't know that this is happening, you will identify a loss in production, but you won't really know what's going on. Then a couple of slides about validation. So the next slide is about shading. So what we did is we did some validation with drone images. For this site, on the left side, you see a 3D scan of that plant, and on the right side, well, yeah, that's just a picture of the plant. But on the center left, you see the shading in 3 particular locations based on that 3D scan of the plant. And on the center right, you see our shading maps that we get from the monitoring data of that plant. And you can see that both of these match very well. Another example for the same plant on the next slide is that the drone identified some PID happening on this site, and we get that same conclusion based on the monitoring data. It comes up as a combination of 3 different types of losses, but that's where our recommendation engine can come up with smart recommendations of, look, we are seeing a combination of these losses, which could point towards that you have PID, and recommend to examine that. And then just a last slide, just to let you know that we are launching next week our Analytics Insights package, which contains all of the things that I just showed about loss identification with the recommendation engine, etc. So that's it for me. Thanks a lot.
Thank you very much, Julien. So let's move to the final presentations, and then we can open up the discussions with questions from the audience as well. So the last presentation is from Luis Ramon Castillo, who is Solution Manager at Huawei. Luis, if you can switch on your camera, the floor is yours.
Hi, David.
Okay, Luis.
Thank you for the introduction and the invitation. Happy to be here. So my name is Luis Castillo. I'm Solution Manager for the Digital Power Business Department in Huawei, UK. Today we're going to talk, before starting with the presentation today, as you know, Huawei is a product manufacturer. We started in this business with a string inverter, and after 6-7 years, we have increased our portfolio to other areas. We have, first of all, we have increased the float of inverters. We are looking into transformer stations now. We can provide a solution, battery storage, and also at all levels of the market, residential, commercial, and utility scale. So moreover, our department has grown into data centers, EV charging, and so it is somewhat something that we are looking not just at the solar PV part, but as a digital power business in total. But besides the product, and what I'm going to discuss today with you is that we are also looking at the system now. We only provide you a solution as a component, as a simple equipment, but also how to support and help our clients with the system, with the PV, mainly on the PV business. How can we bring solutions without altering the hardware or the equipment that you need, enhancing the performance of your site in terms of operation, or also for the operation and maintenance. So perhaps we can go to the next slide. So the first will be what we internally call a smart DC system, which this is a feature that we have been working for a couple of years, and now we are starting to have some pilot projects around the world. As you can see, we have done some tests in China, in India, and Spain. And the idea is mainly through the inverter and a smart logger, which are equipment that you normally will have in a solution with Huawei, give a information of the IV curve of what is happening on site at the IV curve level to the tracking, because as you know, conventional tracking will normally follow the astronomical path of the sun, which it might not be ideal to extract the whole yield, especially now with the introduction of bifacial modules, where the backside of the panel brings another component, another variable to the tracking, and if the terrain is irregular, and also if you don't have a clear sky day, but you have diffuse radiation. So these are variables very complex to analyze, and you require a lot of data because you also need a fast response. So the idea is every tracker or every set of trackers to be tracking independent from each other. And it's quite interesting because you will increase the solution of, the yield of your site by only the way you operate it, by only changing the way you track. As I say, we have done some tests before, and the results are very promising, between 0.5, maybe 1.5% increase in the yield just by changing the way you track. At the moment, one of the main challenges is compatibility with tracker manufacturers, because we have a protocol of communication, then the tracker manufacturer might have another. But this is something we are working on, and it should be a battery that we will clear in very soon, and we should have this as a standard solution very soon, next year. Maybe we can go to the next slide. On the maintenance side of the solution is our smart IV curve diagnosis. This is something that we have had very, very good feedback from our clients, and essentially what you will be able to do is an IV curve test remotely. As you know, normally you need special equipment and special conditions to go on site, and then you will need time to evaluate these results if you do it through the conventional way. But with our tool, you can do this remotely. You can do it for 100% of the strings on your site, and you will have the results within minutes. Just to give you an idea, about 100 megawatt worth of strings can be done in 15 minutes. So this is a really huge difference comparing to the conventional way of doing this test. Also, you will have a type of fault. We have certified 14 type of faults, so you will know what is the type of fault that you are having in your site, and you will be ready to attack this, to clear this fault. And you will know the location of the string, so you will not waste time going around site finding the string that is damaged. Perhaps we can go to the next slide. And my last slide is also about in terms of safety, mainly for commercial rooftop application. It will be our AFCIs or arc fault circuit interruption feature, which, as you know, the arc fault detection depends on electrical noise, which could be very difficult to detect accurately, because several factors in the system, even temperature or the way you arrange your cable or the way you connect to your cables, if you have optimizer or not, they could change the electrical noise and the signal, the arc fault signal. So in order to detect this accurately, this signal, we have developed a algorithm based on AI that frequently gain more accuracy as the system is used, and has led us to a very high, let's say, accuracy rate using this feature. I think this is all I wanted to present today. So if you have any questions, you can contact me and we can discuss further. Thank you.
Thank you very much, Luis. So I'm inviting everyone to turn on their camera so we can start the discussion. So Will, Julien, Hannes, yeah. Wait, yeah. Okay, there we go. So thank you very much for the presentation. We have a few questions from the audience, and of course I also have a few questions for you guys. I will try to merge some of them together. Maybe to start with, there is a question to myself, which is on which metrics we have developed to assess the impact of failures. This is key to convey return of investment to solar companies in integrating artificial intelligence and data-driven approaches. Indeed, I have actually a specific question on that to the panelists later on, but let me start by answering that. One of the metrics that we have developed, for instance, is a metric that goes beyond performance and is what we call the cost priority number. So it basically converts downtime losses and cost of fixing a failure into euros per kilowatt per ticket. By having this metric, you essentially can manage to benchmark ticket by ticket, asset by asset within a certain portfolio. But let's move to the first question to Will. So it's two questions into one more generic and one more specific from the audience. So Will, in terms of using drones, what do you think the role of drones will play in the future of solar, and new services like that goes beyond infrared imaging, like electroluminescence? Do you think they will become more state of the art in the future?
Yeah, so I think the role of the drone in solar is sort of, it is now an ongoing tool for asset management and maintenance, right? So being able to cover large expanses of modules in a short space of time, reaching modules that are difficult to access, whether that's the size of the table on the ground or commercial roof. So they have a role to play. I think as the regulatory restrictions on fully autonomous drones lightens, I think we'll see more resident drones on solar assets, fulfilling multiple roles from security to auditing of groundworks and sort of on-demand inspections, whether that's visual or thermographic inspections. So I think that's definitely a direction of travel. It's something that we're working with an innovator from Cranfield University on that sort of drone in a box capability. So that's one area. And I think in terms of what drones can do, electroluminescence with a drone is, electroluminescence often follows aerial thermographic inspections. If you want to dig in deeper to root cause and the impact of the anomalies that have been identified through thermography, often electroluminescence is used, and that's usually limited by cost because and sort of the practicality of delivering through, ground-based methods involve back powering and work at night time, etc. So it does become quite an expensive, but it's a very valuable test. So delivering that via drone is definitely something I think the industry would benefit from. So I do think that that's going to become more commonplace within the industry. And there are a couple of innovators sort of working on that space at the moment, including ourselves.
Thanks, Will. Then I'm sure there will be more questions for you in a second round. So question for you, Hannes, and I will again combine the two questions from myself and from the audience. So you presented a specific, let's say, example of snow detection. So the question is that from the audience is that if you are able to calculate the losses associated with snow cover, and my question is that if there are other applications that you are developing at the moment apart from snow detection.
Mm-hmm. Yeah, we actually do. So if I can shortly go into this, so what you will always need to do if you train such an algorithm is that you have a sample set of pictures, and then you will go through, classify it to tell the computer actually that's a picture with snow, that's one with snow on the modules, and so on and so on. And then from this training set, it will derive what is the difference between the pictures and figure it out. So since we were going through the pictures anyways, what we also did is we took a look at the vegetation. So we marked, is there low grass, is there long grass, or is there even vegetation that is actually shading the modules? And by having this classified, you can also run your computer on that. And we also see pretty good results on that. And other applications that are also possible is detecting soiling, for example, or damages after a storm, for example. And so there are many ideas and many things that you can do to actually make use of that. And what I think again is important is that you actually combine that with other data. So for example, if you see that production is low or your expected yield is not met, then this could be a starting point or a trigger for a camera or for a computer to actually look at this point, or maybe even look at that inverter or look at that string, meaning the modules of that string, and see, is there anything I can detect with the camera? Yeah.
Thanks, Hannes. Let's move to a question to Julien. You presented your solution, you presented also the, let's say, your definition of digital twin within 3E, and the question would be, how do you make sure that the digital twin of the plants that you are analyzing is accurate enough before doing the analysis?
Yeah, that's a very very hot topic, of course, and a relevant question, because as you know, garbage in, garbage out. I would say that's not only the case for the digital twin, but it's also the case for the meteorological data that goes in. So and it's one of the things, I guess, that's also being worked on within the Trust PV project. It's something in which maybe drones can play a role, etc. So we are the short answer is that, or the immediate answer is that we have some automated methods to check the configuration. For instance, estimating the number of strings for a certain DC input and comparing that to the digital twin, and sometimes you'll see that the strings are a bit wrongly configured, and from that you can correct that. But the goal is to go more and more towards more automated identification of the digital twin, and so I think it's a very important thing to work on. And then on the meteorological data, or for instance the sensor data, the irradiation data that you use, that's also very important, because if there's an error in that, then there's everything else is wrong as well. So we also have a pretty extensive sensor check that correlates pyranometer data to satellite data to see if there's any deviations there, if they correlate well, or if there are any sensitivities to, for instance, to temperature or things like that. So that's definitely one of the main things we are working on.
Thanks, Julian. Luis, you presented the great things that you can do with power electronics. One question that always comes into my mind when I think about inverter and when we think about data-driven evidence is to really showcase the reliability of inverters. So when do you think it would be possible for the inverter industry to actually show, I say, the proper real bathtub curves in terms of reliability of inverters? When actually is, in a business model, you always include that you need to change the inverter once in a lifetime. Is it really that case? Can you maybe comment on that?
Yes, David, it's actually a great question. Like you were saying, most of the TAs or any conservative analysis, you will look at a refurbishment of the full park of the inverters 12, 15 years ahead of the business. If we are at Huawei, we work on the assumption that our inverter, well, no assumption, we design for a 25-year lifetime of the inverter. I think the reliability that we have proved on the last 6-7 years, all the sites in EURAC 7-8 years, speaks for itself. Unfortunately, I wouldn't think a big statement or a clear statement like the one you need, like if you just want to put a number on they still need more time. I think the industry, the PV industry itself, is still very young. So, but you're correct, that is definitely something that is going to change in 20 years time, because there will be enough data for us to say, okay, we can commit to this. A good example is how we have changed the standard warranty of our commercial product, for example, which is the first generation of our inverters, the 20 kTL inverter or so. It was first 5 years, and then now we offer 10 years standard warranty in some of them. It is because we have that experience backing us with that level of the market, so we can push forward. But believe me, this is something we have in mind. This is something we are looking forward to increase in all of our inverters. And the moment our family of inverters grows older, you will also see this concept of, let's say, the lifespan of the inverter increasing. That's for sure.
Thanks, Luis. So now I have questions that I would like to ask the same question to all of you, and I have a few. And you all mentioned like great services that, to me, is that the added value is clear. However, when you have to approach a customer, the question will be, what is the benefits in terms of cost reduction? Will, you mentioned the 80% of the cost, OEM cost, is human resources, so it's immediate, you can understand that automatizing the use of drones can bring some benefits, but maybe without going too much into details in giving figures, but could each of you give your perspective on the economic added value and what type of the cost, what part of the cost in OEM and not only OEM you reduce thanks to your services. So maybe let's do the other way around. Let's start with Luis and then we go to Will.
Okay, for specifically in our case, for the O&M, I will say, I guess at the moment, giving an exact figure is difficult because it depends on this scenario. But with the IV curve, all the manpower of sending someone to site, because I think even if it is one string or two string, the cost of sending one person to site, you have it there. And also the amount of days that it will take for you to test 100% of the strings on site, which we know on the conventional way is not done precisely because of that reason, because it will be too expensive. So having the capability of doing remotely, I mean, it could mean a significant reduction on the O&M cost when it comes to IV testing. It's either because you want to keep track of your site or because you actually want to detect faults. Like keep in mind that this will also allow you to do IV curve tracing often that you will require, because normally in a normal scenario you will only go for it every 6 months, 1 year, I don't know, 1 year and a half. Here you can definitely increase that frequency because the cost will be reduced. Keep in mind that this is something we base the cost. It will be like a license. You don't need extra hardware more than that you will need from the standard Huawei solution. We will just habilitate you to use the feature, and you can do it as many times as you want.
Thanks, Luis. This is clear answer. Julian?
Yeah, David, I think you alluded to it, but there's the cost aspect and there's the revenue aspect, and I think it depends a little bit on the type of customer what we're looking at. If you have an asset owner using these performance analyses, I think they can really use this to identify opportunities to improve performance of the plants, and often there are studies about these advanced analytics and what they bring in terms of improved performance, and I often see numbers in the order of magnitude of 1% performance improvements, which is of course an average. For some plants nothing needs to happen, and then other plants will have bigger problems that need to be addressed. For other customers it's just a matter of indeed saving time on analyses that they need to do to come to the same conclusions. Sometimes I have like customers, and I show that waterfall plot on a certain plant of theirs because I ran their algorithms, and he said, wow, I knew about this problem, but it took me 20 hours of analysis to get to that same conclusion. And probably in practice it's going to be somewhere in between, where first of all you identify more problems than you would have identified, and on the other hand you spend less time, so you save on that 80% manpower. You save a little bit of time on that as well.
Honest, your point of view?
Yeah. I really agree with you, Julian, that you have to look at these two parts. So there's the revenue, or how much energy can I actually produce, where AI can be helpful. For example, if we look at construction, or what we also saw in some of the presentations, that if you can analyze or model the environment and then find a plant design that actually optimizes the yield, that should be enough of an argument for an investor to actually buy this product or make use of this technology. And then on the other side, the cost factor. If we find solutions that make it easier, in the end cheaper for us as an industry to detect failures, to find damages on modules, this will also benefit the plant owner or the investor, our customer, in the end, because we can offer a more efficient service. So yes, every solution that is going to come up will have to people will ask, is that actually beneficial? But I think a lot of tools will be, and then automatically they will come into place and play a big role in the industry.
Will, what is your take on this matter?
Yeah, so I think I agree with all of those points. I think one of the fundamental things though that needs to change, the industry's been heavily kind of punctuated, if you like, by subsidy fueled assets, and I think that's led to commercial arrangements which aren't necessarily for the good of the asset. And I think in the post-subsidy era, there's going to have to be a big shift in how these commercial contracts work, principally between asset managers and O&M companies, because they're just not designed for the good of the asset. And I think once that commercial dynamic is changed, the appetite and the uptake of some of the services that this group is developing and knows is good for the sector will happen far easier. I think, taking the point that O&M engineers have preventative maintenance activities where they go out and make measurements on the site, and then they're stored in a spreadsheet and put on a file server somewhere and probably never surfaced again or actually used for any sort of corrective maintenance activities. Those things are big prizes for the industry. So although I love all of this technology and how we can make resources more efficient on site and squeeze extra performance out of the assets, the big shift is going to come from the contractual constraints that we're working to at the moment, I think.
There is a question of the audience there. I think it can be answered quite quickly by each of you. Is your specific services, the services that you promoted, can they also be used cost effectively to the residential and commercial market? So maybe let's start again with you, Will.
Well, yeah, obviously the economies of scale are significantly different with residential property arrays. It works for commercial scale roof. The irony is that the commercial roof industry is probably the slowest uptake on aerial services for condition monitoring, when actually they're the most inaccessible assets we're looking after. But it's the sort of the kind of maintenance regime that they typically fall under doesn't necessarily push that to the front of mind of the people who are owning these assets. Yeah, I mean, thermography in residential solar is still going to find issues and add value. Whether it be done by a drone is a question because of congested airspace and privacy rules and things like that. So I know an operator who uses a telescopic pole with a gimbal stabilized thermographic camera at the end of it. That's far more effective for residential properties.
Thanks. Hannes, your point of view on residential and commercial?
Yeah, so the project I was talking about was image recognition. Can we detect snow on a camera? So if you want to take this to the residential field, I mean, you would need a camera, maybe quite a large computer, just for a very, very small plant or very small production availability. So I don't really see that in the moment. We are also looking at bigger plans and a larger scale for that idea first. But I mean, if you think that further, maybe in 10 years or so on, you can have little cheap cameras, maybe with a little thing, technology will still develop. So maybe at some point it is possible and cost effective to have a little visual sensor, the camera, whatever it is, on the sides. We'll see where it goes, but for that part, I think the focus will be on the utility scale plans in the next years. Yeah.
Julian, I know that 3 has a lot of rooftop buildings in their portfolio. So what is your point of view on that?
Yeah, I think the advantage that we have is that our system just uses the monitoring data. So every plant in our monitoring platform has that digital twin configured, has those data, has sometimes a pyramid meter. If not, it's filled with satellite data. So there's no additional hardware requirements to do our analysis. So definitely for commercial, I think that's where we have a lower entry barrier, if you will. It's almost like you flip a switch and there are the analyses. Residential is is always more difficult, whether it can be justified, but even that I would not rule out. But definitely commercial is yeah, one of our focus areas.
Luis, finally, you presented a slide on commercial and industrial, so I can
Yes,
only guess.
yes. So for us, it is the case. We kind of offer the same capability for residential, commercial, and utility. From what I spoke here today, it will be obviously the exception of the tracking algorithm, the SDC system, because it doesn't really apply for residential. But when it comes to IV curve tracing and RFO circuit interruption, yes, it's also focused on residential. Specifically for the residential case, there is a particularity if the system has optimizers, it's not compatible with our IV curve diagnostic tool. But this is something we are looking to improve in the future.
So I'm looking at time. I think there is time for at least one question more, and it's a little bit of a provoking question. Will you already somehow introduce the elements for that question? In some of the services that you guys presented today, but also back to Trust PV, and this comes from my direct experience in talking to several asset managers and so on, is your services, they rely heavily on digitalized assets or on digitalization. Are we actually there? Are we ready for it? Are the asset managers ready to apply those services to the fullest? Who would like to answer to this question?
I'll give it a go. I think what's catalyzing asset managers' attention to this, so we've seen it recently, is that we're now starting to see early life component failure hurting assets, and therefore most asset managers have a problem asset in their portfolio. And I think this realization that when, certainly at the module level, when these components start to fail, many years ahead of when they were expected, if you haven't got digital solutions to how you manage that risk and quantify that risk, whether that's managing spares, repowering, or whatever, then the job of dealing with that is much, much harder. And so I think that's catalyzed people's attention to the need for these digital services. So I think the asset owners and asset managers we talk to are certainly more receptive to these concepts that we've been developing over the last few years.
Does any other opinion on that? Direct experience, internal experience?
Yeah, maybe to add to that what Will just said, yes, I think so too. The need is definitely there, but we are not there yet. So we are talking about digital twins and everything that comes with it, and we see first approaches and also first good solutions, but it's not fully there yet. It's not even almost there yet, probably in the industry, and but everyone's working on it very hard, and it's interesting for me to see yeah, how this goes and how this develops.
Julian, Luis, do you want to add anything on that? Or?
Well,
no.
Sorry, go ahead, Luis.
You go, Julian. Yeah, it's fine for me.
No, I was just gonna say I'm probably in some kind of bubble and only exposed to the people who are seeing the value of digitization. We have 10 gigawatts of assets connected to our platform, and all of the people that I talk to have already gone through the filter of course, being interested in that whole digitization. So yeah, I don't have a broad enough outlook to answer that question in any proper way, I'm afraid.
Luis?
Yeah, well, I'm basically in the same position as Julian. These features really, our solution, and has been always, our client has valued the add-ons that the Huawei solution has, which is normally not the conventional way. We have very, let's say, clients that are used to our innovation since they tried the product, which has changed a lot in the last 5 years. So we kind of also break that threshold.
Well, thanks. Our time is up. Virtual applause from the audience, and again, thank you very much, Solar Power Europe, for organizing this together with the other partners. And I would say thank you very much, the panelists, for your presentation and your participation to the discussion. And with this, I would like to close this session, and let's see each other Solar Quality 2022, hopefully in person. Thank you.
Thanks.
Thank you.
Bye-bye.
Thanks. Bye.
Bye-bye.